I'm going to quickly take you through in this video how we can just use the formula to find an area of a triangle and a couple of examples of this. So it's a little bit of a shortened down version of this. However, if you want to see where this formula actually comes from, and I highly encourage you at least have a look at that, that's in my previous video. But let's just quickly have a look at how do we use this formula, this area equals half AB sine C, to find the area of triangles. Now, what's key here is we're going to label our triangle in a very specific way that is a little bit new, in that we're going to label it with our vertices as A, B, C as capitals. Now, with this, I'm going to deliberately label my C where my angle is, just because this formula is currently written out to have the reference angle at C. So I'm just going to deliberately do that. We're then going to label the opposite sides with lowercase of what's opposite. So you can see here, I've got my vertice of A. This is my side length of A, but I'm just going to do it as a lowercase. Same with the B and same with the C. And we're going to use this method of labeling triangles for all these non-right angle formulas that we're going to start having a look at now. Now, with this formula works when you know the reference angle and the two sides next to it, or the adjacent two sides. That's when you can use this formula. If you don't have that situation, then this formula is not going to work. Like if you had this side, this angle here, and you knew these two side lengths, well, this formula isn't going to work for that situation. So that's something that's really important to note here. Now, with any formula, this is just a substitution game. So you can see here that we know with our formula, it's area equals half AB sine C. So if I want to find the area of this, it's equal to half multiplied by my length of A, which is going to be this length just here, that 10 centimeters. Oops, I don't want to put the units while I'm doing the working out. So it's going to be that times 10 times my B value, which is going to be the 8 centimeters, multiplied by the sine of my reference angle of 49 degrees. Now, what we do here is we just plug it into a calculator. So we've got these handy devices which make it nice and simple to use, and we get an answer that's approximately 30 square centimeters. Now, if you were on two decimal places, it would be 30.19, but I'm just going to round it to the nearest whole number for the moment. Now, it's a nice and easy formula to use. It saves going through a lot of hassle that you would have to do if you only knew the right angle trig. Like I said, if you want to see the proof of where this formula actually comes from, I highly encourage looking at my previous video. However, we do need to talk about one other example, in that this example had the units of our reference angle in degrees. We've started looking at a new measurement of units for angles, and those units are radians. And you can see here in this example that I've got a reference angle of pi on 2, which, just so you're aware, is going to be like, if you think about this in radians, pi is 180 degrees, so pi on 2 is actually 90 degrees, which is, when I think about it, probably an unfortunate triangle to draw when this is actually supposed to be a right angle triangle. But anyway, let's have a look at how would we calculate this using the formula. Well, it's the same thing. We would start by labeling our vertices, and I'm going to make sure that my vertice that I'm looking at, like my reference angle, is at C, and then obviously lowercase for the opposites as we did before. It doesn't really matter how you label A and B, by the way, with this particular formula. So our area is equal to half, as long as A and B is either side of the reference angle, I should point that out, times our A, which is 15, times our B, which is 10, and then multiply that with the sine of our reference angle, which is pi on 2. Now, the reason why I'm pointing this out is when you go to put this in your calculator, you have to make sure that you set your calculator to radians. Now, there's tons of different models of calculators out there. Different calculators will show it in different ways. I know that my class use or are encouraged to use the TIs, so that would be going to your mode button, scrolling down to radians and then highlighting radians, but then you can enter that into your calculator, which I'll just quickly do. Hang on. And when we do that, we find that the area here is exactly 75 square units. In this case, it's square meters. So the reason why I'm just quickly going through that is you're going to start coming across questions that have the units in radians, and it's just very important that you are aware that you follow the exact same process, but you just need to change your settings in your calculator to make sure it's in radians rather than degrees.